Good morning. Today's lecture we are going to discuss the subject design and analysis of algorithm under the topic as introduction and notion of an algorithm. So what you identified from this picture, see both the guys are solving a problem. Yes, solving a problem. How to solve a problem? You have any method to solve a problem? Yes, of course there are different methods to solve the problem in computerized manner, maybe algorithm, flowchart and pseudocode. There are different methods are available. Now in this lecture we are going to discuss about algorithm alone. So definition of an algorithm. Algorithm is a, so initially you know the definition about algorithm as a set of instructions. Here it's a little different. Algorithm is a sequence of unambiguous instructions for solving a problem. You will get an input, you can get an output in a specific amount of time for specific set of input. Yes, your algorithm should be unambiguous. That is, it should be a clear manner. It should be written in without confusion. Okay, that is unambiguous for solving a problem, obtaining a required output for any legitimate input. So within a finite amount of time you will get the output for specific set of input. So if the particular algorithm satisfies these two things, that will give a best efficiency of an algorithm. So this diagram depicts the notion of an algorithm. Okay, in this notion of an algorithm there are 5 important things we are going to discuss. That is a problem to be solved. Which problem you are going to solve, that will be taken, and that same problem will be represented in the format of algorithm based upon the definitions we already completed, and the same algorithm will be converted into programming, converted into any computerized program in any programming language with the help of any programming language that is depend upon the application and the users. For any computer program need input to work. So after processing it will produce a specific output that satisfies the users. So if all the things will be considered as per the norms, it will produce the best effective algorithm. Next topic is about properties of an algorithm. The properties of an algorithm must satisfy while writing the algorithm. That is, non-ambiguity, that is a requirement for each step of algorithm cannot be compromised. So what we discussed earlier in the definition, your algorithm should be unambiguous. That is nothing but a non-ambiguity here. Your algorithm should be clear without any confusion, and must given a range of inputs. Range of inputs plays a major role because some of the algorithm will take only smaller range of input to produce the best efficiency, but not the algorithm will work like that. For example, there are different sorting algorithms are available. The selection sort will not work properly, not give a best efficiency compared to merge sort and quick sort, because it will give a best efficiency only the range of input is smaller. If a range of input is higher, we move on to sorting algorithms like heap sort, merge sort and quick sort likewise. So the range of input should be defined properly while writing an algorithm. There are same algorithm can be represented in several different ways. The same thing can be written in, that is, for example, we take an addition of 2 numbers that can be written in different algorithm format, maybe with arguments, without written values, with written values, with arguments. It can be represented in 4 to 5 ways. And there may exist several algorithms for solving the same problem. So the best example for this property is an sorting algorithms. All the sorting algorithm, it may be a bubble sort, quick sort, merge sort, heap sort, any kind of algorithm taking same set of input and produce the same output, but it can be used different methodologies to sorting an algorithm. Okay. algorithm for the same problem can be based on very different ideas and can be solve the problem with dramatically different speeds. So why we going to write a different algorithm for the same thing means our focus is to efficient algorithm, design an efficient algorithm so that we come across these things. So these are the properties of an algorithm. Next is the characteristics of an algorithm. These 5 are very important characteristics: input and output. So you basically what is an input. Input is maybe 0 element or 1 or more elements may be an input. More quantities are externally supplied. Output is at least one quantity is produced. Maybe one or more quantities may be your output. That is depending upon the problem. And definiteness. Each instruction is clear and unambiguous. These two terms we discussed entirely about in the introduction part. Instruction should be clear and unambiguous, means without confusion you define your problem. That is definiteness. Finiteness, if the instruction of an algorithm is traced, then for all the cases the algorithm must terminate after finite number of steps. So if you are writing algorithm for a particular problem, it must have some termination. It should be completed in a finite amount of time. So that is called a finiteness. Efficiency. Every instruction must be very basic and runs in short time. Okay. So your motive is to produce a effective algorithm. Okay, that is efficiency plays a major role in while writing an algorithm. So efficiency is mainly focused upon the there are two kind of efficiencies we must consider while writing an algorithm. One is the space efficiency, another one is a time efficiency. Space efficiency is not much considered for effective algorithm. For effective algorithm, we must focus only on the time efficiency. Your algorithm must be take only a minimum amount of time to complete the process. That's our motive. These are the 5 important characteristics of an algorithm. So again it represented in diagrammic format. Here the well defined same input and output and well defined and clear and unambiguous. Then finiteness we already. Language dependence, this is one more thing. And feasible. Language dependent means it not any depending upon any particular language. You can write your algorithm in simple natural language, so that can be converted into any programming language. So it's a language dependent and feasible. Okay, it can be worked by anyone, so that it's feasible. It can produce any number of solutions. So steps for writing an algorithm. So what are the steps for writing an algorithm? So initially while you are studying a first year, so you write a language, you write a algorithm like step 1, step 2 likewise. For in this subject design and analysis of algorithm, we have method to how to write an algorithm, because in your textbook Canal 11 the entire problems is discussed in this format. That is an algorithm, so that we follow this method for writing an algorithm. An algorithm is a procedure. It has 2 parts. The first part is head and section, and second part is body part. Okay, so as like a human, an algorithm also have a head and body. Okay, the few topics is come under the head, and the remaining the executable part is represented in the body part. The head section consists of keyword, that is called algorithm, and the name of the algorithm with the parameter list. Okay, the algorithm name, algorithm is a keyword, and the name of an algorithm. Name 1 is nothing but a name of an algorithm, P1, P2 up to P3. This is called a parameter list. Okay, the head section also have the following. Okay, the problem description, input and output. Okay, so these 3 things are represented in the head part. For example, addition of an algorithm, how you write for this head part? Algorithm add. Add is the name of an algorithm, and parameter list, you are going to add 2 number means AB. So here AB are the parameter list. Then how you write a problem description for the same? Adding 2 numbers, adding any non-negative 2 numbers. That description can be written by your own. Okay, that is based upon your understanding, you represent by your words. And input. input is nothing but for adding two numbers. What are the input you needed? The any non-negative integers a and b, that may be given in a input part. Output you give, that is adding a and b produce the result in the another variable called c, that is output. Okay, so these things are covered in the head part. Okay, so this is compulsory for everything, algorithm and name of an algorithm. For addition it's add parameters a and b. Okay, then remaining, next these three come under the head part, then remaining is come under the body part. So all executable, because the head part is not executable, so represented in command lines. And in body part, the body of an algorithm, various programming constructs like if, for, while and some statement like assignments are used. So here in body of an algorithm, programming language constructs. So in characteristics we discussed it's a language independent, but some programming like C, C++, Java have same programming constructs like using if, for, while, that is a conditional statement and while statements. So conditional statement and looping statements are common for these programming languages. So that use some programming constructs, if, for, while and some other statements, so is a break, return statements and some print statement likewise. The common statements may be enclosed with the curly braces, open and close curly brackets, and if, for, while can be ended with end if, end for, end while you must return, and identifier should be begin by a letter and not digit. So here what is the rules for writing a identifier in the C language is the same here. Your identifier should not start with any numbers. Okay. Then input and output can be done using a read, write or print, anything. Okay. So these are the rules for writing an algorithm. So this is an assessment. Please go through it. That's we come to end of our lecture. Next lecture we are going to discuss about problem solving, different other problem solving methods. Thank you.